So the complete combustion of alcohols from carbon dioxide and water forms. So this is what is happening here. You are burning is given off, and but this is not ethanol they are burning, and they are giving carbon dioxide and water. This is complete uh, combustion. Then he says nucleophilic substitute between alcohol and hydrogen to form halogen alkanes. So this is reactions of alcohol. So we are talking of reactions of alcohol. This part is first you classify these are primary, secondary, and tertiary. Of course, the OH is connected to the carbon, which is connected to two more carbons. So this is secondary, and the OH is connected to a carbon, which is connected to, so this is tertiary. Then these are uh, the properties of alcohol. Alcohols are dissociate to a small degree into H plus, so they have a bit of acidity, and the position so is a weaker acid than water. Uh, Even compared to the dissociation of water, the concentration is much lower. So even though they dissociate, it's very weak. Uh, the Even if you put it in water, it will you see this is the electron donating group, uh, CH3 and C2H5. So it will increase the negative charge on the, and so it will so because of the electron, the positive inductive effect of the can affect a more negative charge on the oxygen atom. So the ether oxide will readily accept an H plus even from the water. So it is a weaker acid. So it will take the H plus dissociated from water, and so it is weaker acid than water. It's acting as a base. It is accepting H plus. These are the ways in which you can make alcohols. One is the electrophilic addition. H2O is added to the double bond to the alkene. The other is oxidation of alkenes with the potassium cold. So it forms a diol. And of course, in halogen alkanes, aqueous NaOH, nucleophilic substitution, all these give alcohols. Aldehydes can be reduced to give primary alcohols, and ketones secondary alcohols. And reduction is done by NABH4. These are good reducing agents. And even the reduction of carboxylic acid will give you this. So first it converts to aldehyde, and uh, then to ethanol. Um, and hydrolysis also, ester, it's very, it's a reversible process. So it gives you this with water and with alkali both. It gives you this. This is hydrolysis by the acid hydrolysis and alkali hydrolysis. So these are the reactions of alcohols. Combustion, it reacts with the oxygen and gives a clean blue flame and a good supply of, and its substitution with halogen alkanes. So you have alcohol, it reacted with HCl. This halogen alkane can be generated in situ. That means in the reaction vessel, NaCl, you take H2SO4 and HCl is formed. This HCl goes here and then reacts with this. So this is the activity. Here he's got reacting ethanol with sodium bromide, and the sodium bromide with hydrogen bromide. The sodium bromide reacts with the sulfuric acid to make hydrogen bromide, and it is distilled off. So this is the nucleophilic substitution of this can also be achieved by SOCl2. This is the both, they are both gases, so it's a very pure form. Without the need to heat them, we can also. So this is a they escape, the gases escape, and you get a pure form. We can also use phosphorus chloride and PCl3 and PCl5. The reactions are different, and but this reaction, okay, but this reaction does require heating. So you remember the conditions. And here, this doesn't, so you, this is a test for halogen alkanes because HCl is produced. Test for the hydroxyl, not halogen alkanes, for the alcohol group, sorry. You can get iodides by using phosphorus iodide and bromine, Pb3 or Pi3, depending. Now, these are the reaction with with sodium. So, because this is acidic, it will give you hydrogen gas like water. So, uh, if with ethanol, if the excess ethanol is allowed to evaporate, a white crystalline sodium ethoxide, this is formed. This is a base. So this reaction, this is a strong base. That's why this is getting color. The pink colors from the colorless indicates that has been added together, showing basic nature of the sodium ethoxide. These alco oxides form. These are the basic in character. That's why they sometimes used in elimination reactions of halogen alkanes, so that they extract the H plus and convert it into alkene. So this is the esterification reaction. The alcohol is reacted with carboxylic acid in the presence of a strong acid, and depending on the name, you can get the, depending on what ethanol you get the ester. The name is got from these two parts. Okay, then you can break it apart. Can be hydrolyzed by heating under reflex within this. So if you heat it, reverses the preparation of ester from and the reaction reversible, and you get the acid and the alcohol back. This is called as, even you can get this with base hydrolysis. You get the salt and alcohol. The salt can be you acidified to get back the acid, like just replace the Na plus with H. Uh, okay. Then the dehydration, the alcohol, if you take with hot catalyst of or a porous spot, you catalyze the reaction uh, when alcohol is or hot catalyst of aluminum oxide, and it will dehydrate. This is the setup. You're getting ethene. You have got the ceramic ethanol, and you've got the catalyst of aluminum oxide, piece of, as well as concentrate, also catalyze the reaction. Is using pumice here. And oxidation, if you o- o- oxidize these, you will get the um, carboxylic acid, or depending on whether it's secondary, if it's a primary, and then you oxidize this further, it will become into carboxylic acid. If you, a secondary alcohol will convert it to ketone. Uh, the tertiary won't oxidize. That's you can make out by this, because you see this is turned green. Potassium dichromate has turned green from orange, and that means oxidation has occurred. The mixture turns green because Cr2 O7 is converting to Cr 3 plus, and so oxidation is happening. And here it's not. The tertiary don't, because the absence of the H on the C. So that is the reason why it can't oxidize further. So uh, if you oxidize the ethanol formed, like here you are oxidizing this to form ethanol, and then you further oxidize it, it will form ethanoic acid. Now, this can be achieved by refluxing, because you don't want the ethanol to get reoxidized. You take excess of, so two conditions are required. You need excess of the potassium dichromate, and you need refluxing. You want it to keep it inside the and keep on getting oxidized further. So we have been doing this. Alcohol reacts with to give sodium and hydrogen, and alcohol reacts with in the presence of to form esters and water. Esters can be hydrolyzed, is a reversible process by acid or base. Elimination of water produces alkene. This reaction is dehydration. This can be achieved by passing alcohol over heated pumice or aluminum oxide by using concentrated acid catalyst or by using acid. A primary alcohol can be aldehyde by heating the alcohol gently with acidified and distilling out. You have to distill it out, then it stops at aldehyde. But it can be further oxidized to carbon by refluxing the alcohol. Don't distill it out, reflux it. That means keep it. It keeps coming back by condensing it and keep it of excess of. A secondary can be oxidized to ketone, but not beyond that. Change color from orange to green with the primary. The tertiary cannot oxidized with refluxing with excess because of the absence of one hydrogen there, and because it's connected to three carbons and there's no hydrogen. And carboxylic acid can be formed by the primary by refluxing with excess, and they're also refluxing nitriles. So this nitrile reaction is acid hydrolysis of nitriles, and reflux again. Nitrile is reflux with dilute hydrolysis occurs. We get this, and the carboxylic acid is a typical with pH less than 7 acid. It's got H plus, and it because it's an acidic, it reacts with NaOH, a metal and carbonates to give CO2H2 hydrogen gas, and like normal acids do. And if you reduce carboxylic acids, it will turn back into alcohol. So alcohols convert to aldehydes, the primary, and converts to carboxylic acid on oxidation. You start reducing it, it will convert to aldehyde and then to alcohols. Secondary, this is primary alcohol. Secondary alcohol will turn to ketones, but the ketones won't further oxidize. So they will end here. And you can reduce ketones to secondary alcohol. And tertiary won't oxidize. So because of absence of hydrogen. This is the summary of the uh, chapter. Alcohol.